In this video, we're going to look at bivariate analysis. Bivariate analysis, when you have two variables and you're looking to see if there is a connection or a relationship, or if we say, as we say mathematically, if there's a correlation between the two things. Now, the first thing we can do to indicate a relationship is we can draw a scatter graph plotting one of the variables against the other variable. So one maybe goes along the horizontal, one goes on the vertical, and then you would end up with a scatter graph like we have here. So you've got a series of points in this one, and you can see there also is a line of best fit. So you imagine you do that well with a ruler, and you would get a line of best fit. Now this indicates in this one that there is a positive correlation, because as one value increases, so too does, as one variable increases, so too does the other one. So something with a large horizontal variable would also have a large vertical variable. So whatever those two things happen to be. So it may be something like height and arm span, and you would expect somebody who is taller to have a larger arm span. So your arm span is if you hold your arms out horizontally from the side of your body, and it's from the tip of your finger to the other tip of your finger. So you would expect somebody taller to have a larger arm span. It would be up here somewhere, and somebody smaller, much smaller, would have a much shorter arm span. And you can see how we have drawn our line of best fit. So we've gone through as basically we've got the same amount of points above and below, and we've the tighterly oval that you can fire around all of your points indicates a strength of correlation. So this one would be a very strong positive correlation. Whereas if I had had a few more points here, get rid of that one. If I added on a few more points outside, okay, it would still indicate a positive correlation, but the oval or the ellipse is not quite as tight. So it would be a weaker positive correlation, that one. If we go on to our second, if we go on to our second one here, you can see and it's basically the same thing as our positive correlation. They're tightly formed around the line of best fit, but your line of best fit is sloping downwards as you go from left to right. So this would be a negative correlation. And the last one, if you fire your circle, goes around it here, and it is your ellipse goes around it here, and it's getting more very circlish. So it's very round, so it's not going to be show any significant correlation. Okay, a couple of things. When drawing a line of best fit, they must be plotted through the average coordinate x bar, y bar. So this means you take all the x units and you add them up and you divide by the number of them. So maybe there's 10 of them. So you would add them all up and divide by the number 10 and see what you get for your x bar. So that's your average of all your x ordinates. Do the same for the y ordinates. So you take all your y ordinates, add them up and divide by the number of them. So again, maybe it was 10 again. And then that gives you a point to draw about which to draw. So this actually makes life an awful lot easier. So if you know there is one point, for example, I found out here, this point was my x bar, y bar. This makes life an awful lot easier for me, because then what I can do is just pivot your line around this. So you know it has to go through your x bar, y bar, and then you can just pivot around from there. Once you've done that, then your equation of your line of best fit can also be determined by finding its gradient. So we're using, this is your y difference over x difference, or rise over run, and then substituting a point in and gradient into y equals mx plus c to find the y-intercept. So you could also, if it goes through your y-axis, you could just read that off from the graph, but it is mathematically a better way of doing it. If you find your gradient and then you substitute a point in another point which is on your line, and there's bound to be at least one nice point on your line. Okay, we're going to look at a scatter graph example. This example says, draw a scatter diagram for the table below. So you've got scores in science and the people's corresponding scores in history. I'm going to see, is there any relationship basically between somebody's score in science and somebody's score in history. Now what you've got to do, folks, is put any preconceived ideas that you may have about the relationship between these, because you have to go on the data that you have been presented with. So say you think, well, somebody who's good at history is definitely going to be good at science, and then when you work this out and and the diagram, for example, it comes out like this, your scatter graph, that's your line of best fit, then you would know then, according to the evidence that you've been given in this, then what you'd originally supposed to be true wouldn't be wrong, because this would indicate as the score in one thing increases, the other one decreases. So there would actually be a negative correlation. So we're going to work our way through this with trying to put all preconceived ideas out of our head and see how we get on. Okay, first thing to do in this is to look at your data, your information here. It says science and history. You've got all different values. And have a look at a few of the lowest values that you've got. So the lowest values for science, you've got a 61, 51, you've got a 34 there. 34 seems to be the lowest one. So 34 seems to be the lowest in science. In history, the lowest one is 35. So for both cases, it looks like we'll be starting our axes on 30. There is no point in you starting at 0 if there's nothing happening in this first few while. So if it only starts here from 30 upwards, start your axes here, and it makes it a more meaningful graph. Okay, so that's really what we want to do. We want to see where the best place for you to start your axes will be. Likewise, we're going to look for the highest values for science then. Highest value, I've got a 66 there, I've got a 70, I've got an 80, 84, 284. So I think we'll need to go up from 30 to, so far on our science then, it's going to be from 30 to, well, 84, so we'll go to 90. So this is just a wee sketch to keep us right bottom. And remember, you're putting the first variable goes on the horizontal. So the first variable was the science, so it goes on the horizontal. So for history, again, on history, we're going from 30. It was our lowest value in history. Highest value for history, again, we've got an 84, so do the same. That's quite nice. We'll go for 30 to 90 on both axes. And you can see you've got your history and your science. So there's a very rough sketch. So I would do something like this at the side, just so we can see what we have. Okay, all I have done now, I just paused the video there, and what I did was I've marked on my units, on my markings, so from 30, and then 40, 50, 60, 70, 80, and 90. Same on the horizontal, 30, 40, 50, 60, 70, 80, and 90. We were very lucky here. If I zoom in, you can see, we had got, thankfully, we had got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We had space for 10 units, 10 wee small squares for 10 units. So that means one small square is worth 1 unit, which will make this question an awful lot easier. You're just going to have to go with whatever you can fit in. This was only possible for me to do because we started both axes, our history axes and our science axes, at 30. So ideally, what we would have done would have been the following. So ideally what we would have done is you would have drawn your axes like this. So you would have had the top part of your axes, bottom part of your axes, and you would have done a wee ziggity-zaggity line just to show that it's a broken axis. That's a very poor version of that, but you get what I mean. And then you would have started at your 30, but we would not have had the space to have done that just on this one. So we had to start at 30. Now, in a question like this then, very important we see this, we understand this. In a question like this then, say you draw your line of best fit and you find it crosses bang on 40. So it crosses here at 40. That does not mean that 40 is your y-intercept, because this is not actually where it would cross the y-axis. Because remember, this is only at 30 horizontally. So this tells you this 40 here means when your horizontal value, your x value is 30, your y value is 40. So it doesn't actually tell you when it's not actually your y-intercept, as when your x value is 0, we do not know what the y value is, but it definitely will not be 40. It's going to be an awful lot less than 40. So that's just something just to be wary of. Okay, we're going to zoom out now, and we're going to look at the big picture then, and we're going to look and see how we actually plot these points. So I'm going to do a couple of these for you, and then I will pause the video and do the rest of them, as it is so difficult to do it on this thing. So we're going to look at a couple of them, and as you plot them, tick them off. So the first one we've got here is science score. Oh, first as well, I must label your axes. label your axes. We've got science on the horizontal, and on the vertical it was history. And then we will have a wee look at these. So the first one we're doing then is this score here, which was science score was 66, and the history score, corresponding history score, was 57. So we go along on your science was 66. There's 61, 62, 63, 64, 65, 66. And the history score was, I've forgotten already, was 57. So you go through and you do this. This is very difficult to do on this screen. Very difficult to see. So there is my 50 mark. Let me just check that. Normally I would use a ruler just to balance this up, make sure that's right. So there's 50. So I'm going up to 57, 51, 52, 53, 54, 55, 56, 57. And there I have 57 marked on. So those lines and dots that I put on, I would not normally have those on. That is just to keep me right when I'm trying to do this here. But that's where, so I've plotted now. This is a science score of 66 and a history score of 57. So there's the first one done. Okay, I'm going to pause the video and then I'm going to struggle my way through doing all of these, and I will tick them off as I go along. Okay, so pause the video, and then when I start back again, you will see all of my 9 points, I think it is, will be plotted on. Okay, I've struggled my way through and I've managed to get my 9 points plotted. You can see I've plotted them with wee X's. So I've got a point here, 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 2 points here, a point here, a point here, and a point here. Next thing I'm going to do is find my average point. So to find the average points, what I need to find is the totals of all these things. So I'm just going to add up. I'm going to say total equals. So when I added up the totals of all the science scores, I got 552. When I added up the total of the history scores, I got 567. There were 9 of them. So I'm just going to say my mean point is going to be equal to, so it's going to be 552 divided by 9. And it's going to be 567 divided by 9. So I'm just going to say that that means my x bar, y bar, and my x bar, y bar, remember, is a point which my line of best fit must go through, is 61.3 and then 63. Okay, so I'm going to pause the video, I'm going to plot that point and label it, and then I know I have to put my line of best fit through that point. Okay, so you can see I've got my x bar, y bar point labeled, and I just label it with a wee dot with a circle around it. And then my line of best fit has to go through that. So when you're doing your line of best fit, try and get it going through so it is drawn such that there's the same number of points above or below your line of best fit, and if possible, it can go through one of your points. So one of the points I know I'm going to draw mine through is this one. As it looks, it will go. My line of best fit will go something like this. So that's the sort of shape it could go. Now, the pivot point makes it so much easier because you could just pivot and go, put your line there and go, your ruler there, draw along that line and think, that's not quite right. That's maybe too flat and so on. So that's why I've gone for something going through this one. So again, I'll pause the video again. So you can see I've got my line of best fit now drawn. Next thing we want to do is we want to find the actual equation of your line of best fit. So, what we're going to do is pick 2 points. So there's 2 points on my line which have worked out well. So we're just going to say pick 2 points. And the 2 points that I have picked which are nice, which are on my line, are 84, 81, and we had 30, 39. So I'm going to use these as my 2 points. Now to get my gradient, I'm going to use these points and I'm going to do my y difference, which is going to be 81 minus 39 over 84 minus 30. And if I do that, I get 7 over 9. Now, if I put that into my y equals mx plus c, it now becomes y is equal to 7 over 9x plus c. And then what I'm going to do is sub back in one of those points. So sub in 84, 81 I've just picked. And then that means 81 is equal to 7 over 9 times your 84. And then plus your C. And a wee bit of working out, you get your C is equal to 15 and 2/3. So what we have found so far is your y value, or your line equation of your line is y is equal to 7 over 9 x plus 15 and 2/3. Now the question says 10 students scored 70 in history, estimate their science mark. So just say the y value, remember, is your history. So when y is equal to 70, that means 70 is equal to 7 over 9 times your x plus 15 and 2/3. And a wee bit of working out that will give you, well, we'll just do a wee bit. 70 minus 15 and 2/3 is equal to 7 over 9 times x. Divide across by the 7 over 9, and what you will get is 69 and 6/7. Okay, which you would expect to be about right. That looks fairly similar, because most of the way along your line of best fit anyway, the y values and x values matched up quite well on your line of best fit, so that looks pretty good. This example says, for 30 observations, it is known that sigma x is equal to 120 and sigma y is equal to 180. If the line of best fit passes through the point 18, find the equation of the line of best fit and the value of x when y is equal to 11. Okay, question I guess I'm going to have to reread it again. I've missed something here when I've read this. So read it again. It says for 30 observations, and there it is. Okay, 30 observations, it tells you. So that tells you your n is equal to 30. So that's the very first thing, and I missed it. N is equal to 30. Why we need this is, remember, your x bar, y bar is equal to all of your x values added up, which is sigma x over n, all of your y values added up and divided by n. So we can then work out your x bar, y bar. So x bar, y bar is going to be equal to 120 divided by 30, 180 divided by 30, which works out to be 6. So you've got your x bar, y bar, your point, which your line of best fit has to go through, is 6. Okay, next bit of information it tells you, which is important. It tells you that your line of best fit passes through the point 818. So we know it passes through 818 and also this 6. So we're just going to write down our equation for line of best fit. Remember, is y equals mx plus c. And we'll find our m. So m is equal to the y difference. So I'm going to go for 18 minus 6 over 8 minus 4, which works out to be 12 divided by 4, which means your m is equal to 3. So the story so far, y is equal to 3x plus c. I'm going to then sub in. I'm going to sub in 6, just because the numbers are slightly smaller, make life a wee bit easier. So 6 is equal to 3 times the 4 plus c. Continuous over here. That means 6 is equal to 12 plus c. So your c works out to be minus 6. So your your line of best fit is y is equal to 3x minus 6. Okay, last part of this question says, you found equation for your line of best fit. We've done that. And it says, find the value of x when y equals 11. So just say, when, a little word in mathematics makes all the difference. When y is equal to 11, 11 then is equal to 3x minus 6, which means 17 is equal to 3x, which means x is equal to 17 divided by 3. And 3 goes into 17 5 whole times with 2 left over, so 5 and 2/3. There you've got your line of best fit, and you've got the value of x when y is equal to 11. Last bit of notes we're going to look at today is we're going to look at calculating Spearman's rank correlation coefficient. Now, Spearman's rank is just a measure of correlation ranging from 1, which is perfect correlation, to -1, which is a perfect negative correlation. And 0 is when you're right in the middle, and that's when there is no correlation. So there's absolutely no relationship between the two variables. So this gives us a much more robust, more mathematical way of doing this, as opposed to you just drawing a line of best fit. So for this, each set of data is ranked in ascending or descending order as long as you're consistent. So both are either ranked in ascending order or both are ranked in descending order. And then the difference in each corresponding rank is found, then squared, and then the sum of all differences found and substituted into the formula given. So the formula, this is your formula for, this is Spearman's rank correlation coefficient. R is equal to 1 minus, and then it's a fraction. Top line is 6 over sigma d squared, where d is the difference, divided by n upon n squared minus 1, where n is your number of values. Okay, we're going to do 2 examples, see how this works out. So there, I'll leave the formula on the board so we can, on the screen, so we can see it. Okay, first thing we're going to do is, it says 2 judges score the following acts out of 10. Calculate Spearman's rank correlation coefficient and comment on its value. Okay, we've got magician, dancer, singer, comedian, ventriloquist, impressionist, and we've got Simon's score and David's score, and I'm going to rank in descending order. So the one that has got the best score, the highest score, they're going to be ranked 1. So for David, or for Simon, sorry, he's got to give the impressionist 10 out of 10. So that's ranked first. Then second for the ventriloquist, third for the comedian, fourth for the singer, fifth for the dancer, and sixth for the magician. David saw things slightly differently, and he thought the ventriloquist, he gave him the best score he gave was a 9, so it was for the ventriloquist. Then he put the impressionist second. Then it was third for the singer. Then it was fourth for the magician, fifth for the dancer, and sixth for the comedian. So next we want to do is find the D. So D is the difference. So 6 minus 4 is just going to be 2. 5 minus 5 is going to be 0. 4 minus 3 is 1. 3 minus 6 is minus 3. 2 minus 1 is 1. And 1 minus 2 is minus 1. Then we want to square these. So 2 squared is 4. 0 squared is 0. 1 squared is 1. Minus 3 squared is 9. 1 squared is 1. And minus 1 squared is 1. So at the side here, I'm just going to do sigma d squared. So we add those up. 4 plus 1 plus 9 is going to be 14, plus 1 plus 1 is going to be 16. So you get your sigma d squared. In this question, we had a total of 6 different entertainers. So we have n is equal to 6. Your r is equal to 1 minus, so I'll just zoom in so we can see this a wee bit, 1 minus, it was 6 times sigma d squared over n upon n squared minus 1. And then all we're doing now is filling that in. So that's going to be 1 minus 6 times 16 for our sigma d squared. And then it was 6 upon, and that's going to be 36 minus 1. And when you fire that in, what you get is 19 over 35, which is 0.52. No, so it's quite a bit off 1. 1 was a perfect correlation. It is definitely a positive correlation, we'll just say, which indicates, and we'll just say, a moderate positive correlation. So there is some relationship, but it is not really, really strong. And that is it. Okay, last example, we're going to look at what we do if there is tied ranks. So we just jump straight to this example, and it says, calculate the Spearman's rank correlation coefficient and comment on the correlation. So if we have a look, first of all, we'll just say that your n is 10. So we'll just mark that in. There were 10 people involved here. And we're going to rank in ascending order. So 14 was the lowest, R's revising, so that's 1. Then the next lowest is the 16, so it's 2. The next lowest is the 17, but 17, there are two 17s, there's a 17 here and a 17 here. So really this would be the third and the fourth value, so but they're both equal. So add 3 and 4 and divide by 2, and what you get is 3.5. So they both get assigned a rank of 3.5. Okay, so I'll just get rid of all that. So there's 3.5 for the 17. So remember that had taken us up to rank 1, rank 2, rank 3, and rank 4. So next one we want to do then is our 20. So we've done rank 1, so rank 2, rank 3, rank 4. So 20 is going to be our 5th rank. Next one then is 21. It's going to be our 6th rank. Next one is 22. It's going to be 7th. And next one is 23. It's going to be 8th. And then we've got our 9th rank is 28. And our 10th rank is 29. So there's our 10 values. Okay, same idea we're going to do for the S. And our lowest S is, our lowest score then is 75. So it's our first one. Then we have 77. It's our second. Then we have 78. It's our third. Then we have, okay, right. Then we've got 84, 84, and 85. So that would be our 4th rank, our 5th rank, and our 6th rank. So 4th plus a 5th plus a 6th, divide by 3, what you get is 5. So all of these get ranked 5. Okay, so they're all ranked 5, those 3 values. And that took us up to the 6th rank, remember? So the next rank we put down will be our 7th rank. So our 7th rank then would be the 89, 7th rank. And then our 8th rank would be the 92. 9th rank is a 94. And the 10th rank would be this one here, our 96. So add in a line for D, your rankings, and then D squared. So D, remember, or D is not the ranking, sorry, D is the difference. So you're doing your H minus rank H minus your rank S, which is going to be -1. That's going to be -2. That's going to be 2.5. That's going to be 2. And that was rank 5. I rubbed that out for some reason. How did that begin? Sorry. So that's going to be 5 minus 5 is going to be 0. That's going to be -1.5. That's going to be 6 minus 5 is going to be 1. 9 minus 7 is going to be 2. 2 minus 3 is -1. And 7 minus 9 is -2. And then square all of these, you're going to get 1, 4, 6.25. You're going to get 4. You're going to get 0. You're going to get 2.25. You're going to get 1. You're going to get 4. You're going to get 1. You're going to get 4. So sigma D squared is equal to 27.5. When you add up all your D squareds, you get 27.5. So R is equal to 1 minus 6 times sigma D squared divided by n upon n squared minus 1. And then if you fire that in, that's going to be 1 minus 6 times 27.5 divided by 10 times 100 minus 1. And if you put that all into your calculator, you'll get 5 over 6. 5 over 6, which is equal to 0.833. So we'll just say, so that's a fairly strong, so strong, again, positive correlation. Okay, so there is how you deal with tied ranks. So if you have a read through this bit as well, I give a wee bit more explanation, but I think that has covered it in that example.